So for number 1 on page 187, we had to use the compound formula. Make sure you know these formulas for your test. You plug in 5,000 for your initial amount, 1 plus your rate converted into a decimal. It was compounded monthly, so 12 over 3 years. Just type this in my calculator, you're going to get that out. The only trick to the problem is that it asks you what's the return on your investment, so you have to subtract away your initial investment. So your return is only $1,641.35. Number 2, you also need to make sure you know this kind of formula for your test. This is the compounded continuously formula. You have $1,500 compounded continuously at a 7% rate over 25 years, and that yields $8,631.90. It asks you to compare that amount to what would have happened if it were compounded annually for the 25 years, and that would have yielded $8,141.15. And subtracting these two, the difference is $490.75 cents. That one should not be there because it's money, so we need to round to only 2 decimal places. And so this is actually the answer. Make sure you subtract them because it's asking you what the difference in the amount was. Number 3, you have to find the rate. So 300 equals your 250, 1 plus your rate over 4 because it was compounded quarterly. 4, and then for 1 year. So then I divided over the 250, and you're going to get 1.2. And then I took the 4th root of both sides so I could get rid of this 4 up here, or this 4 right here. 4th root both sides, and you get to this. Subtract the 1 over, and then multiply your answer by 4. So you get 0.18645, or a rate of 18.654%. Number 4 is a simple interest problem. It's one of the first formulas we talked about when we started doing exponentials and logs, and it was on page 156 at the very top. The key here, or the keyword, is depreciate, so we're going to use the minus version. So I started with $20,000, 1 minus the 22% or 0.22 over 5 years, which means in 5 years the car is only worth $5,774.35. Number 5 is trickier than all the problems above it. First thing you should do is you plug in the 280 and the 250, and you have to solve the equation for K. So I divided over the 250, and then I converted to log form, so you end up with an ln of 1.12 equals 10K. Type this in your calculator and divide by 10, and you should get that your K is approximately 0.0113. Then you have to take this and plug it back in, and here's the trick. It says how long it's going to take the amount that you had to double. Well, you started with 250, so you could have plugged in 500 here and then the 250 here for the P. I did the problem so that as if I didn't know what my initial amount was. It doesn't matter what your initial amount is, because if you plug in 500 here and 250 here, when you divide the 250 over, 500 divided by 250 is 2. I just called P my principal, so I needed on this side to have twice of P. So when I divide my P over, again, I still get my 2. You need to know that trick for your test. You're going to have a problem that does something like that on your test. Then I convert to log form. My base is E, so I use ln. ln of 2 equals 0.0133t, divide by the decimal, so it's going to take 61.341 years for the amount that you started with to double. Go back to Edmodo, and then we're going to talk about these problems.